This is example 6 from chapter 1C. We're going to cover absolute deviation and standard deviation. In this example, we look at the Formosa mountain dog, also called the Taiwanese dog, and it was originally kept by Aborigine Taiwanese as hunting dogs. And so you can read through these paragraphs. You can also check out Wikipedia online, where I got this image from. There's lots of great information about this dog breed. The reason we're studying the Formosa mountain dog is because they are getting close to extinction. Only a few hundred of these dogs remain. And so there's a group of people trying to conserve the breed and keep the breed from extinction. So these are the known measurements about the Formosa mountain dogs. So we have proportions when they look at the ratio or the fraction between the depth of the chest and the height at the withers. So the withers, if you don't know, is that ridge between the shoulder blades on a dog. And so that ratio is 4.5 to 10. So if the depth of the chest is 4.5 inches, then the height of the dog from the ground to the withers between the shoulder blades would be 10 inches. So that's the ratio for this breed of dog. Similarly, we have the relationship between the height at the withers to the length of the body. So you can see 10 to 10.5, that's telling us the height of the dog is pretty close to the length of the body because they're similar numbers. And then the length of the muzzle to the length of the skull, we see the length of the muzzle is a little bit less than the length of the skull. Here are some of the size and weight for the dogs. So male dogs are typically in inches, 19 to 20 inches tall. Female dogs, 17 to 19 inches tall in this breed. The weights, the male dogs are 31 to 40 pounds, and the females are about 26 to 35 pounds. Of course, in Taiwan, they use kilograms and centimeters, so those numbers are written here first. We're going to look at distributions from 2 different groups of female dogs that they're considering using for breeding to preserve this breed and save it from extinction. So the Taiwanese conservationists are considering which group of dogs to choose for breeding and preservation efforts. So part A asks us, based on these weight measurements, so these are 2 graphs of weight, which female population is better for Taiwanese conservationists to choose for breeding to save the Formosa mountain dogs from extinction? Or in other words, which distribution is more likely to consist of purebred or closer to purebred female Formosa mountain dog measurements? And then explain our reasoning. So over here on the left are the dogs from Miaoli County. N equals 80 tells us there's 80 dogs in this histogram. Their mean weight is 30.588 pounds, and their median weight is 31 pounds. Over here is a distribution of female dog weights from Yilong County. Again, there's 80 female dogs in this group. The mean weight, 30.575, really close to the mean weight for the dogs of Miaoli County. And the median weight is the same, 31 pounds. So we have a mean and a median that are really close for these 2 distributions. So we have to take a look and say, visually, does it look like one of these distributions might be better for preserving the dog breed? So we said here both groups have 80 dogs. Both means are close to 30.58 pounds. And both medians are the same at 31 pounds. So over here about Miaoli County, I said more dogs are spread further from the mean and the median. So if you look at your number scale down here, here's 30 pounds. So the mean and the median are both right over here. But we have a fair amount of dogs, maybe right around 26 to 28 pounds, and some dogs out here that are close to 40 pounds. If we look at Yilong County, more of the dogs are closer to the mean and the median weights here in the center. So the Yilong County dogs are more consistent. They're not as far spread out. So we talk about deviation now. So we would say the dogs in Yilong County have less deviation because they're closer to the center. They're not as spread out. Here are dot plots of heights. So in the last graph we looked at weights. Now we're going to look at dog heights. These are random samples from the same 2 different population groups of female dogs with these characteristics of Formosa mountain dogs that they're trying to preserve. And again, Taiwanese conservationists are considering which group of dogs to choose for breeding and preservation efforts. So if we look over here on the left graph, Miaoli County, the dogs are pretty consistently spread out between 17 to 19 inches. 2 dots means there's 2 dogs who are 17 inches tall, 2 dogs who are 17.5 inches tall, etc. If we look at Yalong County over here, more dogs are closer to 18 inches tall, and there's less dogs that are on the outside of the dot plot at 17 and 19 inches tall. So our first job is to compare the mean heights, and I said mean sample heights for each of these groups. So in Miaoli County, I added up every value because each value of a dog is represented by a dot on these dot plots. So I added 17 twice because there's 2 dots here, so 2 dogs had heights of 17 inches. So I added up the height of every dot, and then I divided by 10. So we're working with a small data set so we can do these calculations by hand. If you have more than 10, go ahead and let StatCrunch do these calculations for you. Yalong County, again, I'm calculating the sample mean, so I'm using X with the bar in my notation here because it's from a sample. It's not the whole population, just 10 dogs in each group. And again, I'm adding up the height of each dog in this dot plot. So I added 18 4 times because there's 4 dots here stacked up at 18 inches, meaning 4 of the dogs in this sample were 18 inches tall. I add that up and divide by 10. Lo and behold, both of these groups have the same mean of 18 inches. I'm not surprised because if I look at Yalong County, I see that's a perfectly symmetric, balanced dot plot with 18 in the center. So the 2 dots at 17.5 balance out with the 2 dots at 18.5, and then 1 dot at 17 balances out with the 1 dot at 19. Think about it. If you're averaging 17 and 19, the middle is going to be 18. Similarly, if you're averaging 17.5 and 18.5, the middle is going to be 18. If you look over here at Miaoli County, you can see there's 2 dots at 17. Well, there's 3 dots at 19, but 1 less dot at 18. So you can kind of see how things balance out there as well to give that mean of 18 in the middle. So I don't think we can decide which dog group is better just based on the mean height. So I said here the mean heights are very close. We can't conclude with reasonable certainty which group is better to choose for breeding. So let's look at the shape of the distributions to decide which group is better for breeding. There's a couple different ways we look at distances from the mean. So one measure that statisticians use to study the variation or change of a data set is the absolute deviation from the mean, or ADM for short. So I set up 2 tables here to calculate the average deviation from the mean, the ADM, for each dog group. So for Miaoli County, each of the dogs here is represented by an X. That's the values here. And then the mean is over here. Oh, and I'm sorry, the mean is 18.1. I told you guys it was 18. So my scan cut off. This should say 18.1 up here for Miaoli County. But still very, very close to 18 inches. So if we say this first dog who's 17 inches tall, subtract 18.1, we get a negative 1.1. But we don't want to think about negatives because we know if you add up the negatives, they might cancel out. So we convert everything to positive. So the absolute value bars here on that difference make this a positive 1.1. So you can go through and check the calculations for each row of the table. And then at the end, we sum up all of the absolute deviations for Miaoli County. All the differences from the mean add up to 7. We can do the same thing for Yalong County. So for that first dog who was 17, 17 minus 18 is negative 1. The absolute deviation there would be 1 for that dog. And then we do this for all those dogs. There were 4 dogs at 18, and that was also the mean inches. So all of those dogs have distances 0, and their absolute deviation is also 0. So when we sum up the absolute deviations for Yalong County, we get a total of 4 there. So already I'm thinking it looks like Yalong County has less deviation from the mean. Not surprising thinking of this picture up here where more of the dogs are centered around 18. So the way we find the ADM is to add up all the absolute value columns, which we did, and then divide each by 10 because there's 10 dogs in each group. So the ADM, absolute deviation from the mean, for Miaoli County, 7 divided by 10 is 0.7 inches. The ADM for Yalong County is 4 divided by 10, or 0.4 inches. So Yalong County has a smaller absolute deviation from the mean. That's telling us more values of the dogs in Yalong County. More of those heights are closer to the mean height. So if I was breeding dogs and wanting a consistent height, I would want to choose the dogs from Yalong County. Another measure of spread is called the standard deviation. And this is actually more commonly used. And StatCrunch will see that StatCrunch reports to us the standard deviation, not the absolute deviation. And statisticians prefer this method of squaring to get positive distances rather than the absolute value, because if you've got a big data set, sometimes I work with data sets in the millions, a computer can square faster than it can take the absolute value. So if me, your professor, is computing many calculations on a very large data set with hundreds of thousands of rows, I often set up my statistics computer code, and then I take a coffee break while the computer takes a couple minutes to calculate. So it could be Yalong County and Miaoli County. If we've got millions of dogs in these data sets, it might take a few minutes, and I'm going to save time doing the standard deviation, which squares, instead of the absolute deviation, where the computer has to check, is it positive or negative? So if you study computer science, you'll be thinking about these things, runtime and computing time for algorithms and statistics calculations. So in Miaoli County, we take all the same differences for the dogs. And here we only have 10 dogs, so we're not too worried about computer time. And then to convert from negatives, we go ahead and square our data, because that's another way of making positive values. So here's all the squared distances. And we do the same thing for Yalong County. Find the difference and go ahead and square those values. And of course, Yalong County had all these zeros because it had a lot of dogs right at the mean of 18 inches. And so when those square, they become 0 also. The formula for computing standard deviation looks like this. Kind of complicated looking. So we just did this part, x minus the mean, and then squared that. This big sigma out here, it's the Greek letter sigma, it means add it up. In Excel, if you want to add up your column, the symbol to add it up is this Greek letter sigma. And then we divide it by n minus 1. So in this case, n is 10 dogs, so 10 minus 1 is going to be a 9 down here we divide by. And then we take the square root. And the reason we take the square root is to get back out of the squared units. Because imagine if you've got inches over here and you're squaring them. These are inches squared, a unit that maybe doesn't make too much sense in this context. So when we square root it, we get back to just inches for our units. So let's do our calculations. In Miaoli County, if I add up this column here, I get 5.9. I divide that by 9, and I get 0.6556. This is called the variance before we take the square root. And so in StatCrunch, when you run summary stats, it'll also sometimes give you the variance. Just know you take the square root if you want the standard deviation. StatCrunch will typically give you both the variance and the standard deviation. Over here in Yalong County, when I add up this column, I get a sum of 3. 3 divided by 9 equals the 0.3333 if I round. That's our variance here. So already we can see there's less variance in Yalong County. And then you might ask, why does the formula divide by n minus 1 and not n? So up here we were dividing by 9 because that was 10 minus 1. So since these dogs are samples from the population, not the whole population, there could be some outliers that we didn't include from our random sample, we divide by 9 instead of 10 to account for the fact that there could be higher or lower values not in this sample. Our sample mean height could be biased, and we don't know the population mean height. So this slight difference of dividing by 9 instead of 10 makes our sample standard deviation estimate a little bit larger, which statisticians find more reliable for estimating. Sometimes people say we're leaving a little more room for error or a little more of a fudge factor so that we've got a little more room in our margins of error. This technique of divided by n minus 1 instead of n is known as Bessel's correction and is only necessary when we don't know the population mean. Now in real life, most of the time I don't know the population mean when I'm doing statistics calculations, so most of the time I use this Bessel's correction. All right, the last step to get from the variance to the standard deviation is take the square root. So this 0.6556 was known as the variance for Miaoli County. I take the square root to get the standard deviation, and that is 0.8097 inches if I round. Similarly for Yalong County, I take the square root of the 0.3333, which was our variance, and I get for my standard deviation 0.5774 inches after I round. You can check the calculations here. I ran this in StatCrunch, which is how we're going to do the standard deviation from here on out. And I love StatCrunch. It gives me 8 decimal places. And you can check if you round, you get the same results I got by hand. You don't want to be doing this calculation by hand because it's really easy to make a mistake with squaring and subtracting and adding up then. And then square rooting after you divide by n-1. Much better to outsource arithmetic like this to a computer. You showed somebody at some point in your math career you could add and square and subtract, divide, square root. So we let the calculator or computer do all this work for us. All right, so based on our calculations of both the ADMs, the absolute deviation from the mean, and the standard deviations from the samples of these 2 groups of female dogs, can you make a recommendation to the conservationists about which group is better to use for breeding? So the recommendation I made is to say that Yalong County has more dogs closer to the mean height, whether we measure the standard deviation or the absolute deviation. Excuse me. So I would say to breed more consistent dogs, we recommend using the female dogs from Yalong County.